So that thing I just gave you is a triangle. It's a very famous triangle. If you've never encountered this before, that's okay. You'll see it more the longer you hang out in math land. So the triangle that you just got a copy of is called Pascal's triangle. Yeah, Blaise Pascal, I believe, was his name. Blaise, French mathematician, I believe. So, anyways, if you really wanted to go down a deep, dark rabbit hole, doing a little bit of internet research on Pascal's triangle, if you're a math nerd, would lead you on quite a journey. If you're not really that interested, it would probably be a pretty short journey. But Pascal's triangle has tons and tons of different applications and all sorts of patterns and not maybe secrets. That sounds a little kind of mysterious, but all sorts of cool stuff hidden in Pascal's triangle. We are interested in only one of its uses right now, and it's binomial expansions. So before I talk to you about the triangle, I just want to kind of show you kind of up close and personal what it is that we're working with here. So if you took, watch out now because we're going to start doing math, okay? If you take x plus y, and I'm going to use x's and y's instead of a's and b's. So I'll try to stick with that as often as I can. If throughout the course of an assignment you see a's and b's popping up, well, you just got to deal with that. But x plus y. If I take that binomial and I raise it to the power of 1, I just get x plus y. Enjoy that. These are just going to get progressively more, maybe not difficult, but it's certainly annoying and taxing. Now we're going to take x plus y. And we're going to raise it to the power of 2. So what we're doing right now is called an expansion. We're taking a binomial to a power and we're expanding it. X plus y squared is a nice condensed form. X plus y squared can be expanded out into its full self. Anyone know what that would be off the top of their head? Brady?
Plus x, 2xy plus.
Nice work on square, square, multiply, double there. And I can go through those steps with you here in a moment, but nice job, Brady. X squared plus 2xy plus y squared. And in case you're wondering, that's just, that comes from, I'm going to switch colors here. What he just did is, I'm sure he took the shortcut, right? I'm assuming, but he just did x plus y times x plus y, just did it a little bit quicker. And if you FOIL that out, you just multiply everybody by everybody. You know the drill. Then it comes out to x squared plus u plus 2xy plus y squared. This is where, in just this small example is enough to really make us appreciate, I hope, what we're learning today. But we're going to manually calculate x plus y to the third. Again, we're going to expand it, is what I should say. You think of a good strategy for this?
Abbreviate and multiply it with.
Yeah, I mean, really, she kind of chuckled while you were saying that, but that's exactly what a logical person would do. Is you would say, well, x plus y to the third is really just x plus y times x plus y squared. Like effectively, like Brady said, take the previous answer and multiply in a new factor. So let's do that. So we're going to take, show some work on this one for sure. We're going to do x plus y times the answer to x plus y squared, which is x squared plus 2xy plus y squared. How many multiplication problems are we going to have to do to get through this? 6 is the perfect answer, right? You clearly understand the whole multiplication process. X as a multiplier has to go 1, 2, 3. And then y as a multiplier has to go 1, 2, 3. So perfect answer. 6 math problems. What's the first red answer going to be? X cubed. What's the second red answer going to be?
2x squared y.
So plus 2x squared y. The third red answer? So plus xy squared. Make sure you give me a verb before you give me the term, okay? Plus or minus. Let's do the yellow terms. What's the first yellow answer going to be? Plus x squared y. Notice that I'm writing it below the other one because I know that those are going to wind up being like terms. By the way, we're not going to be doing this manually like this all out. This, unless you want to do more, this should be the last one that we have to do this way. All right. And then we'll look at how we use Pascal's triangle to do this. There's still some work involved, but not as much. What's the second yellow? Plus 2x y squared. And then the last yellow is what?
Plus
Plus y to the third, right? And now if we combine like terms downwards, of course, and since if you've been kind of following along with what I'm doing on the board, then you see that the like terms should already be in line with each other. And so if we just go straight down the line, our answer is x to the third plus 3x squared y plus 3 x y squared plus y cubed. So I don't really know what order to ask you these questions in, but I guess my first question is like, as mathematicians, we look for patterns. What did you see anything pattern-wise that you can sort of identify that is beautiful about that answer? Say again. Yeah, so look at the pattern of the x's. How would you describe the first term? It's all x's, right? No y's. And then what happens as we head over to term 2? The x decreases and y says, hello, I'm here. So then y has shown himself and increased up to 1. What happens in term 3? Same pattern. X goes down, Y comes back up. And then in the last term, X says there's no more of me, so I'll show myself out. And then Y shows its full self. And so that balance of the X kind of starts high and works his way low. And then the Y starts low and ends high. You see kind of how they change positions as we go throughout. Good. So that's the first observation that I hope we all made, is that there's that beautiful symmetry in sort of how one decreases as one increases. A little kind of a song they did, a dance they do. What else do you notice? And this would involve now looking at the thing that I gave you about 10 minutes ago, the triangle. Do you see any relationship between this in the red box and something that I gave you in Pascal's triangle? Good. So you're the first one, I think, to spot it. Maybe some others of you spotted it, but the numbers that we're looking for, and in case you're wondering what numbers I'm talking about, I'll make them yellow for you. There's a 1 right here. There's a 3 right here. There's a 3 right here, and there's a 1 right here. And those numbers, not coincidentally, can be found in that row of Pascal's triangle. And if you look above that, you would also notice that earlier when we did x plus y to the second power, look what we got. We got 1, 2, 1. And above that, in Pascal's triangle, when we did x plus y to the power of 1, we got 1x plus 1y. So these numbers that I'm kind of vandalizing up here in yellow, they can be pulled directly out of Pascal's triangle. By the way, Pascal's triangle, in case you didn't mathematically crack the code, pick any number anywhere in the triangle right now and look at it. And then look at the two numbers that are above it. They'll be like diagonally his parents, and add those two numbers together. Do you see it? So Pascal's triangle comes into existence of natural causes, sort of. It starts with a 1, and then it begins. And so the outside row is always or the outside kind of first element, if you will, is a 1. And you go 1 plus 1 is 2, end with a 1. And then you always start, your caps are 1s, and then you go 1 plus 2 is 3, 2 plus 1 is 3, So you can create your own Pascal's triangle very quickly. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Everybody see it? Having said that, do you think that you could help me predict without going through what we don't want to go through, what x plus y to the power of 4 is going to expand into? We know it's going to start with all x's. Good. And then we just find the right row of the triangle and start copying numbers down, right? What's the first number after the 1? 4. So I'm going to put plus 4. And now all I have to do is understand that, again, that dance that the x's and y's perform with each other. What will my x and y balance be? X goes down by 1 and y appears. Good. Next term is a 6. The triangle tells us 1, 4, 6, 4, 1. So we know the next term is a 6. And how many x's? How many y's? Good. Next term? How many x's? 1. Y's? Last term?
What?
Good. And that was about 30 times quicker than if we had done that by hand, right? And you can imagine it gets more and more time saving as we expand up into powers of 5, 6, 7, 8, God forbid, like 10. But with Pascal's triangle, it's pretty easy. The first modification I want you to take note of with me is what happens, do you think, if we change from x plus y to x minus y? Everything doesn't quite switch, but every other one does. So like, we're going to follow the same pattern. So you look at your row of Pascal's triangle. By the way, it's called the 5th row. The top row with the 1 is actually called the 0th row, just for the record. So we can call the one with the 5, even though it's 6 layers down, it's still called the 5th row, FYI. So go to the 5th row, and the numbers are 1, 5, 10, 10, 5, 1. So let's begin. What's our first term going to be for x minus y to the 5th?
X.
X to the 5th. This is where we have to make a modification now. We're going to subtract. And so every other term now is going to be flip-flopped. That's all you got to know about the minuses is they're just going to cause a waffling back and forth and back and forth. So next term is minus how much? 5. Give me the xy.
Episode 1.
Y appears. Good. Next one.
Add X to the third and 5%.
Nice. Next one. Minus 10. X down, Y up. Next one.
Plus 5 X Y.
Last term. Fantastic. So far, so good. So that is it's called a binomial expansion, and now they're going to get more difficult. And not necessarily just because I'm going to increase the size of the powers. In fact, quite frankly, on the first one, I don't think I am. What changes now is that we're not going to always be like saddled to these little wimpy, pimpy, baby binomials. We're going to have more complex things like this. I have all sorts of different ways that I can explain this to you, but I think I'm going to go with the old standby, and that is to just use lots of parentheses. So what I'm going to do as I go through and I perform the expansion, me and the triangle, is whenever I get to any place I would want to normally put x, I'm not going to put x, I'm going to put 3x. And whenever I get to anything where I would be inclined to write y, I'm going to put some parentheses, and eventually I'm going to go backfill it with 2y. So step one to be good at this is just to perform a generic expansion, leaving blanks where the inputs normally ought to go. So we're going to first look at the 4th row of Pascal's triangle, and we're going to start with blank to the 4th. Again, don't put anything in there yet. When you get better at this, which will be pretty quick, then you can start filling things in at your own discretion. But for today, for now, nice and slow. So there is the artist formerly known as x to the 4th power. The next one is going to be plus what?
3 points.
Since we're on a power of 4, then you need to be looking at the row of the triangle that has 4. So the next term is going to be plus 4. Blank to the what? And blank. See it? Don't put anything in there yet. Just following the template. After the 4, so I'm going to put plus 6 blank exponent on the first blank. Second blank. Good. I'm just going to kind of keep scooting this over here. And then the next one is a plus 4. First blank is just no exponent. Second blank is what? To the third. And the last blank is, or the last term is plus blank to the fourth. Good. What we're going to do now is we're going to go back through all the blanks. And in any first spot, we're going to put not X, but what? Good. So 3X goes here, 3X goes here, 3X goes here, 3X goes here, and that's the end of the X's. And then in all of the second blanks where there normally would have been a Y, we're going to now go backfill and put in 2Y. Still okay? And now it's time to simplify. So now that we've gotten all that out of the way, it's time to go in and do the math. So does anyone know what 3X to the fourth is? I mean, I could just tell you if you want. Oh, you want me just to tell you? Okay, so it's 81 x to the fourth. It's because I had to take 3 to the fourth and x to the fourth, so that's that. Now the second one is going to be, I believe it's going to be 216. Let's talk about why that is. So when you look at this mess, I'm going to put a purple underline underneath of it right here. It's just its own little math problem now, a little isolated sort of thing. What would go first in that math problem? The exponent should always take precedence. You can't say parentheses because there's nothing to do in the parentheses, so that doesn't count. The exponent takes priority. So only what's in this purple box can be what we do first. And what's that going to equal? 27 x cubed. 3 to the third is 3 times 3 times 3, which is 27. And now that you've cleaned up that mess, you can go through now and combine multiply all of your constants together. So I'm going to, they're my factors. I'm going to take 4 times 27, which is 108, and then 108 times 2, which is 216. So we have 216. And that's just going through and sifting out all the numerical parts. But the x's we already knew what they were going to be. X to the third and Y. Like that was a foregone conclusion. Next one, again, we've got just some localized sort of cleanup to do. So first priority is to do the purple box, but we also have to do the yellow box. So what is the answer to the purple box? 9x squared. Very good. And what's going to be the answer to the yellow box? 4y squared. It's imperative that you free everybody up from the parentheses first, and then you can go gathering and then grab all the loose pieces and put them together. So again, just math. What is 6 times 9? No, like multiplying the numbers? Of course not. There, it's all going to come out in the end. And then 54 times 4 is coincidentally another 216. So we get plus 216 x squared, y squared. Okay. Took a pretty big leap from the last problem to this one. As soon as you start throwing coefficients on those terms inside the binomial, it gets a little nasty. It's not unmanageable. It's just gotta kind of keep track of stuff. Let's head on to the next term. So the only one I need to draw a box around this time is the yellow box because the red one is just, it's got no exponent. What's 2y to the third? 8. Y to the third. And then again, in any order that you want, these numbers with the red arrows pointing to them can be multiplied in any order that you see fit. If you see a more logical order in which to do it, then that's always your right. That's just called the commutative property. You just do math in whatever order you want. What's 4 times 3? 12 times 8. So we have plus 96, predictably xy to the third. And then the final term should be pretty stress-free. What is 2y to the fourth? No, 16 y to the fourth. You went a little heavy. You went a little heavy on that one. That's 2 to the sixth you were thinking of. 64 is, you got a little grande there. That is how you generally do what we call a binomial expansion. And we're using the binomial theorem to do this. I mean, if you were to Google the binomial theorem, you've been warned. Watch out. You're going to see lots of exclamation points and n minus ones and all sorts of things that are going to make your skin crawl. But at the end of the day, what it boils down to is just use your Pascal's triangle, first of all, and then recognize the pattern of the powers. It all starts full x, and then x diminishes, and then y introduces himself in the second term, and it ends full y's. And all the stuff in between is just really meticulous keeping track of the math. So having said that, let's talk about what your assignment is going to say. By the way, there will be some problems that are just do the full expansion, like that. Boom, done. And then there's going to be some problems that say this. So you don't need to do, if for some reason you want to, you're welcome to, but we don't need to do the full expansion. If someone asks us for a specific term, then I can just lay out the numbers. First thing go ahead. Yeah, so you're going to go to your Pascal's triangle and you're going to find the row that starts with a 7. And you're going to say the first term, second term, third term, fourth term, and Bryn nailed it. It's going to involve the number 35. Good for you. And there's one other consideration to make. You remember what effect this minus has on our overall answer? It causes us to go positive, negative, positive, negative, positive, negative. So will the fourth term be positive or negative? Okay, so we're going to have negative 35. And then the only other consideration we have to make, and this is to me the only part that kind of hurts the brain a little bit, is what's going to be the balance of x's and y's? Because we're on the fourth term out of 7. And so if it helps you, and I mean, I don't know, maybe it's just me. What I would do is I would start by writing, okay, first one is all 7, no y's. All x's, no y's. The next one is 6 of these, 1 of these. Next one is 5 of these, 2 of these. The fourth one, what I'm looking for is 4 of these, 3 of these. Do we agree? You can see that that's the dynamic. That's the little dance that the x's and y's are going to do, right? So what we now know is that the fourth term is going to be negative 35 blank to the fourth times blank to the third. Why in this case are the blanks unnecessary?
It's just x5.
Because it is literally just x and y. So this one, bless you, would just be negative 35 x to the fourth y cubed. See it? Had I asked you for the fifth term, then you would just look on your triangle just like Bryn did and say, I know exactly where to go. Boom, I got your number. I got to understand the dynamic between the x's and the y's. Pay attention to the signs. That's about it. So let's try a more challenging one. Sound good? Everybody got that down? Hang on, did you say? Okay. Let's find the sixth term of 2x plus y to the 9th power. So first thing we're all going to do is go to the row that starts with the number 9, right? And we're going to count 6 across from starting at the 1, of course. So that's going to be 1, 2, 3, 4, 5, 6. We should all agree that the number that we're looking for is 126. Anyone have any issues with that? Okay, let's think about now the variables, the weight of the x's and the y's. It doesn't take long to make a list like this, and there are formulas out there for this, by the way, but I find that it's not worth it in this case. So I'm just going to write them out. It starts out all x's, no y's, and then you simply go down, up, down, up, down, up, down, up, down, up until you get to the term that you want. And since we want the sixth term, the one we want has a 4 and 5 leading coefficients. Good. All right, so we know now that we want to do 126 blank to the fourth times blank to the fifth. And again, one of those blanks is unnecessary. Which one? The second one, correct? Because again, your math teacher just gave you a generic y. So since there's no coefficient on it, there's no need to put blank. You could just change that to say y to the fifth. So the only real the only real math here is to plug the actual first term of the binomial into the blank. And that is this 2x is going to go right there. Easy peasy. So having said that, we're going to have 126 times 16 x to the fourth times y to the fifth. And then at that point, it's time to grab a calculator and clean it up. 126 times 16 is 2016. So if you were some sort of masochist and you were to actually, God forbid, multiply out 2x plus y times itself 9 times, the sixth term of your answer would be 2016 x to the fourth, y to the fifth. Pretty cool, powerful stuff there. Do you have any questions about that? Do you think you can handle doing some of these by yourself? Because that's what I was doing over here off to the side. So I just like to write them all out. So like I knew since I was doing an expansion of the ninth power up here, right? So I know that the exponents are always going to add to 9. It's going to start with 9 x's and no y's, right? And then the second, so this is the first term. This is the second term. We'll have 1 less x and 1 more. So I just wrote them all out until I got to the sixth term. Okay. Anything else? I think this assignment is on Delta Math, and I think honestly maybe it's been there for a while. Let me pause this and I'll take a look. So Brady, what does your problem say?
Find the second term of the expansion 3x minus 8y.
Just for the record, in case you're not listening, you should. Brady's question was, do I put this in as a negative? And I wouldn't, quite frankly. I would just understand that it's going to be blank to the third minus blank squared blank plus blank blank squared plus, excuse me, minus blank to the third. If you just do it this way, then the negatives will all be taken care of for you. Am I making sense here?
Mhm.
And then when you put in your parts and pieces, just put 3x in place of all of your firsties, and then just put a normal 8y in place of all your secondies. And then the minus is already built in and you're all taken care of. Does that make sense?
Mhm.
That's how I would personally do it. If you wanted to be some sort of masochist and try it some other way, you could, but that's going to be your best bet. So like in your case, your second term is obviously right here. So that's going to be a negative, that's going to be a negative term, right? You with me? Okay, so we're going to have minus 72. So that's negative 72 x squared y. Do you see it?
Minus.
Part of me thinks I should take it off the recording, but I'm going to leave it here. I'll own this. Brady, we did this together. We forgot to put the 3 here and the 3 here. So yeah, it's 72, but it's times 3. So it should be negative 216 x squared.
I did it.
Gosh, apologies for that. What a knuckle fart. Yes, ma'am. I can, sure. I'll just,
Yes, they do.
Bryn, what does your problem say?
Second term, 8 grams around 2x, 3 was good.
2x just plus 3, no y. Okay. And it's the second term. So first thing is our number. So you should have 1, 5, 10, 10, 5, 1.
That's a negative.
So the second term is going to be this one. So you're going to have 5 blank to the 4th times blank. You good? I can't see that. It's dark in here and it's small. So I appreciate the sentiment, but I have no idea what that says. So you're going to put 2x in place of the first thing here. And then you're just going to put 3 in place of this one here. 2 to the 4th is what would go first because you have to exponentiate first. Right? And 2 to the 4th is 16. And then 16 times 5 is 80. And then 80 times, yeah, I always take care of the number parts first.
Okay.
I don't worry about all that other stuff. So like I just go through and I dig out all the things that don't involve algebra. So 2 to the 4th is 16 times 5 is 80 times 3 is 240. And then you just go through and dig out all your variables. So you should have 240x to the 4th.
Oh, okay.
And then
Joe, you need some help?
That, you have to like work out all along. That was just the not defined.
That would be a full expansion, right? Like if someone says, if this problem had said, give me a full expansion, then we would have had to write the whole thing out.
negative.
But just finding a specific term is nice. What does your problem say? So we want the third term, okay?
Yes.
That's what.
So
Did you get it?
No.
So the power of 4, I go to Pascal's triangle and the numbers are 1, 4, 6, 4, 1. So the third term starts with a 6. Do you agree? Okay, so we're going to have 6 something. And now the question, this to me is always the hardest part is what are the exponents that I put on my chunks? Yeah. So the third term would have been 4, 0, 3, 1. We're down to 2, right. So we're going to have squared on this one and squared on this one. Are you still with me? Okay. Now what's going to go into those 2 blanks? Good. So you got that far from the tone of what I'm hearing, it sounds like. So your job now is to go through and just pick out all the number parts. We know our answer is going to be some number times x squared. Just for the record, like we see that. So the question is, what's the number? Well, you sift through all the rubble to figure it out. So like this right here is 4 squared, which is 16. This right here is 7 squared, which is 49. So you're just going to take these purple numbers, the circled numbers, and multiply them together. I'm getting 4,704.
What I put. Oh, wait, I put X.
You didn't put x squared?
Now I just put square.
Oh,
I'm just stupid.